And now I would like to welcome Emiliano, who's going to tell us when rest is not enough. Welcome.
Thank you very much. Hello, everyone. Thank you to be here today. And thank you very much to the organizers that are incredible for this incredible and warm conference. A few words about me. I'm an independent consultant based in Modena, Italy. Also, I'm the maintainer of the Ruby Asterisk Jam. That is just a jam for interacting with Asterisk PBX using Ruby. The fun story is that I started this jam like 15 years ago. Then I stopped using it because I didn't need it anymore. Then last year, as you may know, Psychic made this jam fellowship fund, and I applied and I won. It's amazing because also Marco Roth, I guess you know who he is, won. So it's really, really incredible for me. And also, I'm one of the organizers of the RubyCon conference after Ruby Day that stopped in 2024. Me and a bunch of friends decided to start another conference in Italy. It's going to be in 3 weeks. There are still tickets, so please, if you want, let me know. And I hope to see you in Rimini. If the weather is nice, it's going to be amazing. If it rains, I don't know. Anyway, so let's go to the topic. Why we are using all REST, or why our first thought goes to REST? Well, first of all, because, let's face it, it's a de facto standard. Everyone knows it, everyone uses it. In a way, it's similar to serving HTML, because it's just the same. We are just serving JSON or XML or any other format you may like. So it's simple, it's efficient, and it's actually really accessible also for beginners, and is the standard in Rails, as you may know. Now, why we shouldn't use REST? Well, if you've followed the DHH keynote at last Rails World, he said we basically are CRUD monkeys. And I kind of disagree because, yeah, at the end of the day, this is what we do. We manipulate data. But are we sure that this is just CRUD? I think that also with the AI revolution, we are building modern apps with really advanced features. And for that, we need the right technology and advanced technology, not just standard REST. Also, the fact is we find ourselves in a hammer and nail situation. We have a really good tool, but it just doesn't fit for any situation. The truth is we need alternatives. REST is just one of the tools we can use. Let's see a bunch of them. First of all, the first I'm going to mention is gRPC. If you were at Euruco, last Euruco in Viana do Castelo, you have seen my talk about gRPC on Rails. Now I'm not going to describe that much this protocol because it would be too much, a matter of 30 minutes just for gRPC. Let's just mention it was released by Google in 2015 as open source on GitHub. It's based on two main pillars. The first one is HTTP 2, that is just the second version, the second iteration, let's say, of HTTP, based on the data streaming, fast data streaming, data compression, and so on, and protobuf. Protobuf is basically a mechanism for data serialization, for serialization and deserialization of data. So gRPC is made for high performance, strong typing, guarantees data streaming, and security by design. What are the main differences between gRPC and REST, you might ask? Well, first of all, I would say that gRPC is much, much faster than REST thanks to the streaming capability of HTTP2 and to the serialization mechanism. On the other side, is much more difficult to integrate because, as we are going to see in the next slides, it's the client and the server basically need to agree on a contract, that is the protofile, and whenever this contract, this protofile change, it should change both on the server and on the client side. So it's really much difficult. If you need to add a function or add an attribute on the server side, you have to change in all clients for the communication to be successful. And it's harder to debug. Because of the serialization, you cannot see what it's really happening between the two sides of the communication. And that could be make things harder for debugging. Now, let's see how to integrate gRPC, for example, on Rails. All the examples are Rails-based, but of course you can use Sinatra, Hanami, or the framework you prefer. You basically start with an initializer that is creating a thread, opening a port on the default one is 50,051. And this is initializer just creates a thread and starts it with the gRPC library. Hopefully you're going to see it, hopefully. This is a protofile, and the protofile consists of a service like that. Sorry, this example is just a simple e-commerce, really stupid, and consists of a service called order service that is made of a function defined as RPC in gRPC, accepting a create order request and returning a create order response. And the create order request is made of a customer ID, a product ID, and a shipping address. You can see the data types here and the position over here that are really important in gRPC, and returning a response, an order ID, a total in cents, and the currency. Starting from this file through a set of tools that are made available by Google for every language, you can get a class like that is always generated every time you run it, starting from the protofile, that just guarantees serialization and deserialization. Then the logic is taken by this class that is subclassing the e-commerce order service that we have just seen. That is quite simple. We retrieve the customer, retrieve the product, create the order, and return the object. Quite easy. So let's see how it works. Left side is the server starting, okay, answering on 5051. Then on the right side, we see a client called grp curl that is just curl for gRPC. Let's see how it works. It accepts the protofile that I mentioned, this sort of contract. It accepts the parameters as a JSON. I've specified product ID 1, customer ID 1, of course, always pre-created, and the address, and the service that we are calling. And as you see, we get order ID, total cents, a currency. Fast, but yeah, this is a simple case, so it's not, but I assure you that I've used it in production in heavily performant production environments, and it's amazing. It's really performant. Now let's see what happens when the product is wrong or is not existent. So left side server, right side I'm changing the product ID, and what we get is couldn't find product. Quite easy. Now, let's talk about GraphQL. Many of you, for sure, have used it. It was released by Facebook in 2015. It's defined as a declarative data fetching and modification, and its main characteristic is to be single endpoint instead of REST that tends to prefer multi-endpoint. It's basically REST just with a payload that defines what objects I want to get or I want to manipulate. And this solves two main problems that were experienced by Facebook at the time: overfetching and underfetching. What is overfetching? Overfetching means I just need one single object and two attributes, and I get like maybe one object but 50 attributes. And this is a waste of resources, a waste of network, and so on. On the same time, underfetching, what it means? If I need 3 objects and I need to make 3 calls to 3 different endpoints, in that case, I can make a single call specifying the 3 objects I need with the attributes and just what I need, and I get it. And it's really, really convenient. In this case, we have the GraphQL gem that allows me to specify a mutation, because on GraphQL jargon, a mutation is when I change something on the server, and the code is basically just the same. I retrieve the customer, I retrieve the product, and I create the order. Now, let's see how it works. I'm starting the server. On the right side, as you see, I'm pasting the command. That is just curl. So it's REST. It's REST, but with a very, very different and specific payload. And what I get is just the same. Data, we create order ID, total cents, currency, as we have seen it before. Now, what we get when the product ID is wrong, as you may imagine, we're going to get an error. But in this case, I'm not showing it, but I had to make some modifications to the code, because otherwise I would have got a 404 page, and that wasn't really pretty to show. Now, let's see MQTT. I don't know how many of you have used it. MQTT has been developed mainly for IoT devices. It has a broker-subscriber architecture, meaning that every client subscribes to a broker. It's a pub-sub mechanism, as we have seen before. What's also interesting is the quality of service concept. Basically, every message, every broker supports 3 different levels of quality of service. It's 0, that is, I publish a message and I don't care how many times it is delivered. 1, quality of service 1, is I post and at least 1 time it is going to be received. And quality of service 2 is I post once and is received just 1 time for every client that is listening. So comparing to REST, what is interesting, and we're going to see how, it's the higher performance of MQTT. And another very interesting feature, in my opinion, is the possibility to make bidirectional communication. Why? If you imagine a situation where an app client on a phone and a server making REST calls to the server, the data process can go the other way around. A server cannot send that data to the phone for obvious network reason. With MQTT, you can, actually. Of course, the downside is that you need to have a broker So it's a more complex architecture and needs maintenance, uptime, and so on. For Rails, we have a gem called MQTT. In this case, I just created an initializer, initializing MQTT client, because on Rails, you create a client connecting to the broker. Then we are subscribing to orders topic, because in MQTT, you have the topic concept. And then when we are subscribed, whenever we receive a message on that topic, we retrieve the customer, retrieve the product, create the order, and so on. Of course, I had to modify my little stupid application to add an MQTT broker. I'm using Mosquito, that is the most common and open source standard. And let's see how it goes. This time, we are starting the server, but we are also starting the broker. And on the right side, I'm using Mosquito Pub, that is the client version of Mosquito. That works just the same. I calling localhost on the MQTT port. This T is the topic orders that we've seen before, and the payload. Nice. Really fast, but if you've noticed, I didn't get any response. Why? Because in this case, the client that is publicating a message publicates to the broker and just stops and just returns. This is the reason why it's fast, because we are not waiting for anything. This could lead to some downsides when the product doesn't exist, because I change the product, I send the request. On the server, I see, okay, but I cannot find the product, but the client doesn't know. Well, maybe the client could know with always this topic mechanism. If I subscribe to a order failed, for example, topic, and the server publish a message on that topic. But as you understand, okay, this will be perfect bidirectional communication, but it's harder to achieve. Now, I know you weren't expecting a reference to LLM. It's incredible, right? And also, if you attended the incredible workshop yesterday made by Pavel, was incredible. I hope I'm not saying any bullshit. Anyhow, MCP as a protocol stands for Model Context Protocol, was released by Anthropic in 2024. Looks like ages ago. It's not, it's just 1 year and a half. It is based on JSON RPC. And well, what can we say? Of course, many of you, if not all of you, have used it. It has been designed for LLMs. That means that in respect of REST, we can say it's LLM ready. Why we can say that? Of course, an LLM, let's say Cloud Code, Windsurf, whatever, of course they can use REST, but for them is much more token consuming. With LLM, with MCP, this is just made for them, and this is the reason why we can say it's token efficient. Of course, on the downside are the lower performances, and we can see on the following slide. In this case, I'm using FastMCP, that it's not really maintained anymore, but never mind, it's just for showing. In this initializer, we are creating the server, specifying a few attributes, a few functions. Then I'm creating a tool, taking as inputs the customer ID, the product ID, and the address as before, and just with the same process we have seen 3 times. In the example that will follow, I've been using Claude, so I specified, I created this small configuration file where I explain to Claude where is the MCP. So let's try. Left side the server, on the right side I'm opening Claude. This time, instead of pasting a very really complicated command, I'm just writing create an order for product ID, customer to, and shipping address. I've called this application Sloppify, but actually, as you see, I've not said create an order on Sloppify. I just said create an order. But as you see on the left, it's working. It's receiving the request. Of course, it's stewing and so on. But hey, after 30 seconds, I got the same thing that I achieved before. But this time, Claude is adding a little bit of magic powder. It says order created successfully with the order ID, with the total already in not cents anymore, but I have the right currency and so on. And shipping too. Great. Now, the real magic is what happens when the product is wrong. So I start running the server, writing the same, and let's see what happens. It will take a while. So you can, but it's interesting for me because it shows you how performances differs a lot from protocol to protocol. But okay, we have my wonderful stack trace, but what's interesting for me is that Claude analyzed it and offered me a solution. He said, okay, it doesn't exist. Could you double check the product ID without me saying anything but active record, product not found? So this is really, really, really interesting for me. Summing up, I will say you should use gRPC when you need to make a communication between different systems in the same architecture, and you need really, really high performances. GraphQL, I will say you should use it whenever you need to make different queries, and in one situation, you need a certain set of attributes and objects, so you need flexibility. And this is where GraphQL wins. MQTT, whenever is IoT, it's MQTT, that for sure. But also, if you are in a setting, in an environment when you may use also a bidirectional communication. And lastly, well, MCP, whenever you have a LLM, that's for sure. Thank you very much.
Are there any questions?
Hello, thank you for the talk.
You're welcome.
I have a couple of friends at Google who told me that gRPC is not used at Google anymore. And
I have one that says the opposite, but it depends.
but from my personal experience, I did experience some problems with gRPC as well, but we found a protocol called twerp, which is kind of an improvement on gRPC, and it uses the prot above. And I really had a lot of good things to say about it. So
How is it called?
twerp.
Twerp.
So I think it was Twitch who developed this. They had a lot of problems with gRPC. I highly recommend it to check it out.
No, okay, sure. Thank you very much. Well, my contact at Google has said they use it a lot, and I believe him. But I guess they're so big that yeah, everyone has his own experience. In my experience, I've been using gRPC in a very performance needed application. Basically it's a fleet tracking application for snowplows. So whenever it starts snowing in Italy, from a moment you're not tracking anything, and suddenly it's like 10,000 vehicles going out. And I really saw, unfortunately, I don't have the graph with me that it's in the Euruco talk slides, but it's impressive. But of course, as I said, it's much more difficult to integrate. This is for sure.
Not that fast.
Sorry. MQTT has bidirectional communication. That reminds me a bit of WebSockets. I know they're not exactly directly related, but how do you compare the two?
Yeah, actually, thank you for the question. WebSocket is something that was in my mind. I was wondering, should I add it or not? I don't think they are the same, because in my experience, how I'm using WebSocket is more when you have a communication between client, a browser, for example, and the server. This is how I use it. MQTT is much for the IoT. As you've seen, I'm publishing and returning. I don't care at all. I don't care at all about actually, there is a broker in the middle. So the broker is not the broker that is answering. You know what I mean? Instead, the WebSocket, I'm publishing to the WebSocket. The server through the WebSocket could answer or not, but it can answer. On the MQTT, it's impossible. Why? Because there is a man in the middle that is receiving and sending the messages. So for me, there's just two different use of for communication.
So if I understood right, MQTT is between servers, whereas WebSockets is between a client and a server.
MQTT, no, I wouldn't. You can use MQTT to make communication between many servers. It's just a different communication, but yeah, I get what you mean. Yeah, you can say that.
Thank you.
You're welcome.
Okay, I think there was one more question, but I lost you. Oh, Ryan, of course.
Sorry, this isn't really a question, it's another non-question.
Okay, so I'm not answering.
in my talk yesterday, one thing that I don't think I actually mentioned at the time is with the shared dictionary stuff, because that is done at HTTP level, you can apply that to APIs as well as like returning other text-based resources. So in terms of using like REST and GraphQL and MCP as well, I presume at some point, but it'll need implementing on the client, you can use a shared dictionary for that. So you could look at like all of your JSON keys that are across all of your APIs. Of course, that shouldn't have any personally identifiable information in it. So you could bring all of those into a dictionary. Same thing for any kind of enum values, because again, that's a specific set of things. You can put those in the dictionary, and then you can then compress every request and response with that. So effectively, you can kind of almost get down to that protobuf level kind of file size. You still have to do all of the kind of serializing and deserializing, so there's still more overhead there.
But it's coming close to gRPC.
In terms of the actual network piece, you're getting pretty close to protobuf. So just
the fact
bonus.
that gRPC needs this proto file that is messing things up.
Yeah, it works around that. Yeah, if you don't know what your API is kind of going to look like, or you want to evolve it quickly, you get kind of the best of both.
If you don't know what it's coming, you cannot deserialize properly, and this is when things go awry.
All right, thank you. No more questions. Thank you very much, Emiliano.
Thank you.